So number 2 takes us on a walk down memory lane. We're going to go back to the blood alcohol content formula that they gave us. And in this case, we're not going to be simplifying it in the same way we have previously. They've already done that for us. They tell us that we're working with a male who weighs 190 pounds. So that means we can plug in the absorption constant for him being a male, the 0.68, and we also plugged in the 190 for weight, except they've already done that, and after they did that, this is the formula they came up with. They're giving us the simplified formula right here. So let's look carefully at what they're asking. So they're telling us that we have a blood alcohol content of 0.09 and that 2 hours have elapsed. And they're asking for the number of drinks. So the thing we don't know is this N over here. And we know the time. And we also know the blood alcohol content. So we're starting right out of the gate here, working backwards from getting the answer to finding the value of one of the variables. So you're going to plug in 2 values and solve for N. Okay, so 2B changes things up a little bit. It says, okay, well, you solved that last one for N very nicely, as I'm sure you did. But now they're saying, okay, we want to do that a bunch of times. We want to be able to plug in a time and a blood alcohol content and come up with an N. So rather than doing that rearranging that we had to do for A every single time, let's just rearrange this formula once and for all and make ourselves a new formula that solves for N. So I'm going to walk you through that process with a different formula to show you what they have in mind. All right, so I'm going to kind of go through a process with this formula here. It's going to be similar to what you're going to have to go through to answer number 2B here. So here is a little old formula, and suppose that we're told that we know that y is equal to 27 and that m is equal to 2, and we want to know what is x. Well, what we're going to do is we're going to plug in the stuff we do know and solve for what we don't know. Here's what I mean. So we're going to plug a 27 in for y. We're going to plug a 2 in for x, and the 5 is going to come down because it's just 5, and now we need to solve for that x. All right, so here's the steps we're going to do. We're going to kind of work backwards like we've gotten used to doing throughout this chapter. And we remember that we're going to have to do PEMDAS in reverse. And since we have multiplication and addition over here, we're going to undo the addition first because that comes after multiplication in PEMDAS. So I'll subtract 5, and I get 22 equals 2x. I only have one operation left. I'm going to undo that, and I get x equals 11. Okay, so that's similar to what you would have done in part A of this problem. But then comes part B, and that question is going to be something like the question I'm just about to ask about this formula here, and that is, okay, we're always going to be solving for x. So let's rearrange this original formula so that it's solved for x, so that instead of y equals a bunch of stuff, it's x equals a bunch of stuff. But we're not going to plug in these 2 numbers that we did over here, because those vary. Okay, those are the things we plug into the formula. Okay, so what I'm going to do is rewrite my formula over here. And I'm going to now follow the same steps that I followed on this left-hand column, except I'm going to do it without plugging in that 2 and that 27. And here's what I mean. So the first thing I did is I subtracted 5 from both sides. So that's what I'm going to do here. I'm going to subtract 5 from both sides. And I get y minus 5 equals mx. So in this first example, I had a 27, so I could just subtract 5 from it and get a number. I don't have a number here, I just have a y, so I have to leave it like y equals 5. All right, so the next step I did on the left after subtracting the 5 is I divided by 2. And I divided by the 2 because that's the thing multiplying the x. So what's multiplying the x in my formula on the right? Well, m. So I'm going to do just like I did on the left and divide by m. And these m's cancel, just like the 5's canceled above here. And I end up with an x all by itself on the right, and on the left, I have y minus 5 equals m. And that may look like a whole bunch of mess, but what it has given us is a formula that is solved for x. In other words, it has x all by itself. So now, anytime I'm given a y and an m value, I can just plug them into this new formula here to figure out what the x is. All right, so let's go back to our original formula in the problem. So we're going to be doing the same thing with this formula. We're not going to plug anything into it. We're going to leave the b and the t and the n all in there, but we're going to do algebra to it to get this n here all by itself. So we should end up with some kind of formula like n equals, or you could have equals n on the other side, but there's got to be some other thing over here. And this thing over here is going to have the t in it, and it's going to have the b in it, and they're going to be rearranged in some different way, and there's going to be numbers thrown in there too. That negative 0.015 and that 0.022 will end up over there in some form or other. And so that's what you need to do for b, is make yourself a new formula that looks like n equals a bunch of stuff with t's and n's in it. So one thing you can do to check your new rearranged formula that solves for n is to go back to part A, because remember in part A we're given a value for b and a value for t. And your new formula that you come up with is going to have a b and a t over on the right-hand side somewhere. So you can plug those into your new formula and make sure you got the same n that you got in part A. That'll be a good trial run for your new formula. And checking will also be a good trial run for doing part C. Because what this is doing is this is giving you a value for b again and a value for t. And since your new formula of n equals something is going to have a b and a t in there, you can just plug in that 0.17 and the 1.5 wherever they need to go in this formula and come up with your new n for part C.